let's have a look now at the collision domains. As we can see, we have a hub right here, and we have 6 endpoints connected to this hub. Each of them have the IP address 10.10.10. Whatever the PC number is. So what I'm going to do, I'm going to send a ping from PC1. We'll send it to PC6. So what should happen is it should just, what we want is it just goes straight to it, but I've got a feeling it won't. Let's have a look. So ping 10.10.10.6. Now we're using the simulation mode in Packet Tracer because I said the simulation of this is really good. So we see the first thing it's going to do is it's going to create first create its packet. You see it's in red because it doesn't know the MAC address of where to actually send the packet to. So what it's going to do is going to send an ARP out first. So let's have a little look and see what's happening. So it sends the ARP out, hits the hub, and the hub now floods it everywhere to every single device that's connected. Okay, so PC6 responds to the ARP request saying this is my packet, but of course being the hub, it now sends that request again out to everyone else. Okay, so now we have the ICMP packet, the ping being sent to the hub. It's got the MAC address of PC6, but of course the hub duplicates that everywhere. We have getting the response back now from PC6, and as we can see, the hub again is sending that information out to every single port. Now that's not really what we want to happen. We want direct unicast communication. So as we know, a ping sends out generally 4 pings at a time, so this is going to replicate, and every time it sends a ping out, the hub is going to send that out to everyone, even though PC1 knows the full address of how to get to PC6. The hub is still going to spread everything out of the collision domain. Now this is very, very inefficient, as we can see. So for 4 pings, it's sending information out everywhere. Everyone's getting a copy of this. Now, I suppose if you have your network at home, you've only got 2 devices or so connected to it, it's not a major problem. But in a big production network where there's hundreds of devices connected, this is the last thing you want. This will grind a network to a halt. And this was just for a ping. Any traffic that gets sent out and it goes through a hub is on the same collision domain. So every single device on that collision domain is going to get a copy of this information. And again, this is something we just do not want. So we can get around this by adding a switch in. Now, while a switch in its default configuration will still do the same thing, it will still on the initial ARP request flood out, but subsequently there'll be unicast traffic going between the 2 devices. We're going to have a look at that in just a moment. Okay, so as you can see, I've switched out the hub for a Cisco switch. Now, what we're going to do, we're going to replicate what we did with the hub. We're going to send a ping from PC1 to PC6. Now, every single port on a switch is its own individual collision domain. However, it's still one large broadcast domain. So what we expect is that when it sends an ARP request out, it should still flood the ARP request out of every single port that it has anything connected to, apart from the one it was received on. However, once the PC knows the MAC address of where it's going to, it should then be able to have unicast one-to-one traffic. So let's have a look. We'll send it to a different IP address this time. Let's send it to PC3. So let's try ping 10.10.10.3. And let's make sure we're in simulation modes. Okay, so as we can see, the first thing that happens is before it can send the ping message, it needs to send the ARP. So it sends the ARP to say, well, where is what's the MAC address of who owns 10.10.10.3, so we can then populate that into the ICMP message. Let's have a look and see what happens. Okay, so the ARP request hits the switch, and then as expected, the switch floods that out of every port, and the only one that replies is PC3. However, you should notice now that the switch no longer does what the hub did and sends it out every port. It sends it directly back to PC1, and now we have unicast traffic for the ping requests. They're going directly from PC1 to PC3 and back again. All the other PCs that are connected are oblivious to the traffic that's going on. They're no longer receiving copies of this. So while this is one big broadcast domain still, because all the ports are in the same assignment, in terms of collision domains and replication, every port is separate. All right, let's have a little look at why this actually works. So if we log on to the switch is a switch at the end of the day, and let's have a look. Let's go into enable mode and show MAC address table. Okay, see, as we can see, this switch has learnt that PC1 is connected on Fast Ethernet 03, and PC5, PC3 is connected on Fast Ethernet 05. It's got the MAC address learned on each individual for each of these. So while the broadcast went out, asking for who owns 10.10.10.3, because PC3 replied, the switch said, this is where that device resides, this is its MAC address. And because when the ping messages are going out, they have the MAC addresses of each individual device that they're going either to or from, the switch knows exactly where to forward that traffic, so it doesn't have to bother sending anything out. So if I was to say go on to PC2 now and say ping PC5, you should get another 2 MAC address entries in there. Let's have a look. All right, so let's go ping 10.10.10.5. Okay, so it's following the same format. It's going to send the ARP request out to say who has 10.10.10.5. And the only one to reply will be PC5. So now what's happened, the switch knows the MAC address of PC2 and PC5 and where they're actually, what ports they're located on. So now any traffic that's destined for PC5 from PC2 or even from PC1 or from PC3 will be able to go directly because it has these entries in its table. See, as we can see, the pings are just going back and forth, unicast from one PC to the other. No other devices are involved with this. Now, if we have a look at the switch's MAC now, we should see more entries. Okay, so we see we've got an entry for Fast Ethernet 01 and an entry for Fast Ethernet 04. So that's the basics of how the switch is learning the location of these devices, and this is why the devices can now communicate unicast one-to-one without having to flood and be replicated to all the other devices. So while there's no longer any issues with collision domains, this is still one big broadcast domain. So if you have, again, in a network that has lots and lots of devices, you may want to segment that, and that you can do with routers or VLANs. This is something we'll have a look at in just a moment.